So let's take a look now at the HP, the calculator. And I'm going to be using my HP calculator, but I'm also going to use the calculator, the electronic version of it from time to time. So I'm just going to overlap this here. And I think it might actually even stay. We'll see. So I've got this live calculator skin. I think I sent to you guys through WhatsApp or somewhere the link so you can put this on your desktops or your laptops if you'd like to. And we're going to look at how you use the calculator's time value functions. Are any of you very comfortable with and familiar with the time value functions of this calculator? Well, just raise your hand if you are. So not as comfortable as you'd like to be, because I can tell that a few of you are showing a lot of confidence here. Well, you're going to be a lot more comfortable with it in the coming weeks, I promise. Okay, and the best way to get comfortable with this is to play with the darn thing. And we'll go through some scenarios that will give you examples of how you might play with it. So I'm first going to talk about using the top line functions. So these very first row here and the functions that are in white. In I divided by YR, which is interest per year, present value, payment, and future value. Okay? So those are the 5 variables in an equation. And if we have one equation and one unknown, we can solve for that variable that's unknown, right? But there's actually a 6th variable that we've got to consider here. Your calculator is so smart that it is stupid. And you'll understand as we go through the evening why I say that. But we have to tell it how many periods per year. So that's a tantamount to there being a 6th variable. And the way that we do that is the periods per year function is right here in the top row, second from the right, PYR in red. So to activate that, we have to use the red secondary key. And I'm going to say that I want to make sure that I'm going to use 1 period per year. So 1 red PYR. And it tells me that I'm 1 period per year, okay? You can check to see how many periods per year your calculator is set at by doing a clear all, which is red, clear. And it tells us 1 period per year, okay? Or maybe I'm doing something monthly, 12 red PYR. I want to check it, clear all, 12 periods per year. I can't tell you how many thousands of time value functions I've done on my calculators. I have 3 of this calculator, and I have 2 of these, and I have this app on each of my computers. I don't even know how many thousands of times I've done this. That said, every time, and I mean literally every time I do a time value function, I set my periods per year first. I do a clear all to check to see where I'm at, and if need be, I change the periods per year, because the single most common error that people make, and they may not realize it, and they've then got a spurious outcome. So set your periods per year first, and then if you know 4 of the 5 variables, just plug them in, and you will solve for the 5th. However, here's the stupidity and brilliance. When you're putting in the number of periods, N, you have to tell the calculator literally the number of periods. Let's assume this was a 5-year loan that we were calculating, and it's a monthly payment. Well, the number of N would be the months per year times the number of years, or 60. So we can't tell it 5, even though we've already told it 12 periods a year. We can't tell it 5. We need to tell it 60. Okay, that in and of itself doesn't seem all that problematic for us. So we have to give the actual number of periods. But for the interest rate, IYR, we give that as an annualized rate. So we don't give it as 1/12 of 6% for if we're using 12 periods. We would use 6%. And by the way, you don't use 0.06. You use 6. So the IYR key and the N key are not correlated as you and I would expect them to be using common sense. Now, there is a reason in the programming of the calculator why they did it this way, but most of us don't appreciate this. And I think about 5 more minutes of programming, they could have done it so that most people don't have this curiosity or problem. But this will cause consternation for some of you. So the N is the actual number of periods of time. The I divided by YR is the annualized interest rate regardless of the number of periods of time. and it's expressed as a percentage, not as a decimal equivalent. Well, payment is a payment. It's the interest payment, received or spent. Future value is a future value in dollar terms, and present value is a present value. We can solve for any one of these five if we have told it the other four. Okay? And again, here's the equation that it's working with. Any question about that? Let's do an example. So we've got, we're going to use one period. Let's see. We're going to use one period, 6% interest. We're not going to have any payments, and we're going to use a future value of 100. This, by the way, is that first number that I looked at. So we're going to set this. I'm going to make sure that I am at one period per year. I am. I'm going to call n is equal to 1, and I don't say n first. I do 1 n. So you give the value, and then you give the function, and 6 I divided by yr, 0 payment, and 100 future value. And the present value is going to be, well, what did I do?
I think you have to put minus sign. One of the numbers should go minus.
That's not why it's doing this. Hang on. Did I do my n is 1? I may have this as a typo here. Excuse me, because this doesn't make comment. It doesn't make sense as B74. This is a typo. I'll correct that. I apologize.
That's what I got too.
Okay,
I walked through it with you.
Yeah, I got 94 as well.
Okay, yeah, it's a typo on my part. I apologize. So we may see that again. I may have carried that typo on. Excuse me. So it's $94.34, but it comes out as a negative. And Solomon, you gave us a clue to this just a second ago. This calculator is using this equation. And I don't know any algebraic equation where a positive on the left-hand side equals a negative on the right-hand side. I don't know that algebra, but apparently the calculator does. It's used to that algebra. So what's it really doing? It's using what's referred to as an input, output, or stack flow architecture. It doesn't matter that you remember those terms. It matters that you know a convention. And that convention is when you're inputting values into the calculator that you're going to receive money coming in. Well, in my life, money coming in is positive. So I put those in as positive values. And the convention I use is if money going out is negative, so I put those in as negative values. So in this case, I would have to pay $94.34 in order to get an investment that will give me $100 5 years from now based upon a 6% return. Why did I call that a future value, though, rather than call it a payment? Well,
because that's what you're going to receive, maybe, if
I'm going to get
invest
that at a point in the future, right, Solomon?
Yeah.
I'm going to get at a singular point in the future. If I had called it a payment, then it would assume that I get that payment every year. Well, for 1 year, it doesn't matter. But let's change this. Let's assume that it's going to be 5 years instead. So if nothing else is going to change here, I can say 5n. So I still have the 6%. I still have the future value of 100. Well, I'm going to change that to, in fact, I'll just change this whole thing. I'll say clear all. I'm going to start over. I got 5 periods. I've got 6%. Let's say the payment is 100. And the future value, I'm not going to give it one, it's 0. I end up with $421, not 94. Why? Because it assumes that payment happens for every one of the periods. If it's only one time, then we put it as a future value. If we put it as a payment, that payment happens for every period. So we can't control otherwise. Okay? Any question about where we are here yet? Okay, let's keep going. So let's look at this one now. And in fact, this is the one I just did. So 5 years, 5 periods, 6%, $100 each time for each payment, no future value, and it was $421.24. So we had the one-shot transaction. We have multiple transactions with a constant cash flow. Now we're going to have multiple transactions and changing cash flows. And to do this, we now need to move beyond the top line functions. And we need to move into the CF, or the cash flow register. And we'll use the cash flow register combined with a few of the top line values. Okay? So we're going to put in values for cash flows starting with period 0. So the first time we click on cash flow, it believes we're starting at period 0. Period 0 is now, it's not in the future. So if I'm trying to identify the present value of a future stream of cash flows, then my cash flow at time 0 would be what? It'd be 0, it'd be nothing, because that hasn't existed yet. Now, if it was a net present value, I might give it a negative value as though that was the cost of my investment. We'll get to that in an example in just a moment. So in this case, we can go in perpetuity here, or nearly so. You know, as many times we can click this thing, because we've got to be careful with it. And when we put the values in, we're putting them in as cash flows. And every time we click the cash flow button, it's incrementing one more period of time. So we don't have to tell it the number of periods, because every time we hit this, it's incrementing or counting up, and we're telling it on a de facto basis the number of periods. Okay? We will put in the interest per year, and we'll put it in just exactly as we did when we were only using the top line functions. And we will not use present value, payment, or future value. Payment is the cash flows, positive or negative, it's the cash flows. And the reason we can go positive or negative is because sometimes if we're assessing a business, businesses have negative cash flows sometimes. They're not all uniquely positive, and they aren't all nice and neat and constant, and they aren't all nice and sweeping and changing at a constant rate. They can be messy, and if you've ever owned or analyzed a business, you know that very well. When we do our solution, we will not solve using the present value key, even though present value might be what we're trying to solve for. We're going to solve using the net present value key, the NPV key, which is the second row down here, second column from the right, and we'll have to use it by activating the secondary key. So let's give an example on that. So we'll pick up my calculator again. I'm going to clear this thing out. Well, 1 period per year, so I'm safe. And I'm going to input these non-constant cash flows. What's my cash flow going to be for time 0? 0. Yep, nothing. Okay. And then 100 for time 1, 125 for time 2, 150 time 3, 175 for time 4, and then 200 for time 5. Okay, I know that I've got a 6% rate, and I've told it because every time I touch the cash flow register, it added up another one. I'm about to solve for net present, or I'm about to solve for present value, but I'm going to use the net present value key because you have to when you use the cash flow register. And I don't give it a future value. And because I haven't given it a future value, it assumes there is no future value. So the absence of a value is 0 in this construct. So now I will calculate red net present value, and it gives me a present value of 619. Well, I've got another number here, and I think I may have had I may have had an input error of some kind. I'm not going to run back through that for the sake of, that's not true. I am going to run back through it, even though it's the second time, because I want to see what's going on. That's the second time that I've got a problem like this. So,
hey, Rick, I had the 61960 as well.
Do you? So thank you, Nate. I've got a couple of typos in this. Obviously, I'll repost these. I don't know how I got those in there, but clearly my issue. I apologize. Thank you. So I use the net present value solution to find a present value, only because I have to when I use the cash flow register, which is a clue to us that the cash flow register will help us find a net present value. Any questions as to where we are so far?
Rick, I apologize.
No.
You probably said it if I'm actually given a stack from, a historical data from a company, these cash flows, where would I actually see them?
Okay, so if you're given cash flows from a company in its past, those are not
cash flow statement.
Yeah, so those are not future cash flows, so we wouldn't use them to identify a present value. However, and we're going to deal with this in some detail next week, Jason, we're going to need to forecast our future cash flows. Once we have forecast them, we now have a stack of future cash flows, and those are the ones that we'll put in here. So historic cash flows might help inform what our cash flow growth rate might be, but they are not our future cash flows. Does that make sense?
Yes, thank you.
Very good. Solomon, was that a hand?
I was saying if I use T, which is like n is equal to 5, or if I don't use it, I get the same amount. So
If you used what?
Okay, so on the equation it's given T is equal to 5, which I assume it's n, right?
Mm-hmm.
T is time, right? Like.
Oh, did I? Yeah, T is time. And we don't need to put that in here because we counted it up every time we touched the cash flow register.
Yeah, that's what I'm saying. Even if I use it, I tried both ways. I tried using it and I tried not using it. It gives you the same number.
It does. And so there's not a problem in using it, but it's redundant. It's just not necessary. In fact, it literally is ignoring it.
Okay.
You just don't know that. Okay. In fact, you could put 12 in there and it would still give you that same number because it ignores it.
Okay.
Well, we solved for net present value. Give us a number, it should be 619. But in fact, what we really wanted to solve for was present value. So let's take it a little further. Let's make an assumption. Let's see if we can't get this one where it actually gives me the right number. I'm not sure why it's not, but we'll figure it out. And let's assume that we have the same cash flows, starting at 100 in year 1, going all the way out to 200 in year 5. But at the end of year 5, we also are getting a $500 payout. Let's assume there's a terminal value. So this is an investment, and Nate knows that if he buys this, it should spin off these cash flows for years 1 through 5. And at the end of the 5th year, we have some expectation that we can sell it for $500. And that's a cash flow, again, that Nate will get, right? It's just not a cash flow that's spun off from profits. It's spun off from having a terminal value. We sold it, we scrapped it, we did something else to it, okay? So let's see if we can't replicate the values, and we'll see if I've got another typo in here, which I'll feel oh so good about if I do. Some of you don't know me all that well. I don't have to be right all the time, but I hate being wrong, okay, with a passion. So you have to excuse me, please. So I'm back at 1 period per year. I will go cash flow 0, 100, 125, 150, 175. Excuse me. This is a good time to let me show you something. If you do as I just did and click the number too many times, you messed up the sequence, you have a backspace right here, this backwards arrow, and it will let you correct yourself. You see that I use that from time to time. That's cash flow at time 4. And now this $500 that I would get at the end of year 5 if we're selling this investment or scrapping it has to be added to the cash flow for the same year because it's happening in the same period of time. So I will say 200 plus 500 equals, that's my 700, and now is my cash flow in period 5. I'll give it then 6 as interest per year, and then let's see what happens to net present value. I get 993 and some change. Does anybody else get that same number? Okay, good. Well, I feel just a tiny bit better about myself now. So is that a net present value though? It's not. It's still just a present value. A net present value suggests that we have had a cost that we net out against the benefits. And we haven't entered in a cost function here at all. So let's think about how we might do that. We'll look at this next. So let's assume for a moment that I've got a cost function of $950. So in order to buy this investment, where we just calculated that the present value is $993, it's going to cost me $950 to buy it. And I want to calculate the net present value, and I want to calculate the internal rate of return. Okay? Well, the net present value, so NPV, is equal to the present value of the benefits minus the present value of the costs. Well, I already know what the present value of the benefits are. I just assessed them here. They're $993. And if this cost is something that I'm paying out of my pocket today, then that is the present value. Oh, I could take that $950 and I could divide it by 1 plus I don't care what discount rate to the power of 0, and it's still going to have a present value of $950, because any number to the exponent of 0 is going to be that number divided by 1. Okay? So here I can now go ahead and start to plug these numbers in. I believe that my net present value is going to be 4323, because that's the 993 minus the 950. It can be as simple as that. Let's see if I can get that number using the values. So let me bring up the calculator again. Let me go ahead and make sure that I clear the register. By the way, when you do the red clear or the clear all, it doesn't only tell you what your appearance per year is, it clears the register. So anything you have already in the cash flow register clears out and you started at 0 again. Okay. The other reason I always do that, because it's another easy mistake to make. You don't clear your register. So let's start this. I'm going to say 950. That's my cost, and I need to change it to a negative. So you hit the toggle switch here directly above the blue key, change it to a negative, and that's my cash flow at time 0. My cash flow at 1 is 100, at 2 is 125, at 3 is 150, at 4 is 175, and at 5 was 700. Whoops. 700. Okay. Now if I solve for net present value, well, clearly I screwed something up. So we're going to go back at that. I apologize.
I think you missed the rate.
Yeah, I did miss the rate. Thank you. I'm not going to come back. Well, we've got time, so I will come back at it. So 950. It's cumbersome doing this on the screen like this with the mouse, but it helps you see the keystrokes. So 950, 100, 125, 150, 175, and then 700, and then 6 interest per year. And now the net present value of 4323. Okay, so if you know the present value and you know your cost, you can simply take the present value of the benefits minus the present value of the cost, and it's going to give you the net present value. Or if you don't necessarily know the present value of the benefits, you just plug everything in just as I did, and it will give you the net present value. The corollary to net present value is internal rate of return. And so with all of that in, I'm going to calculate the internal rate of return now simply by using the internal rate of return function here in the second row down, the middle button, IRR per year, and it's red IRR. And it tells me that the internal rate of return is 7.23%. So I have a couple of questions. A, does that number surprise us? And B, what is the equation for internal rate of return? Because so far, I've given you an equation for everything we've done in the calculator. Is there an equation that we can use for internal rate of return?
Yeah, I think I know what it is.
Do you?
Maybe. It seems like it's taking present value of your benefits minus your present value of costs divided by your present value of benefits.
I don't think so, but I'll let you work that out just in scratch paper or something for a moment if you'd like to, Casey. Because if it is, then I'd like to know that, but I don't immediately think so. I think it's an iterative number. I don't think you'll find that there's a singular equation for internal rate of return. I think what you just gave may be. No, I don't even think that's gonna work. But see if you can get that to work for us. And in fact, buddy, if that works, I'll buy you dinner. That's how impressed I'm going to be if you can get that to work. Because my limited understanding is that there is no internal rate of return equation. There's a modified internal rate of return equation we'll have to think about in a few minutes, and you can clearly do internal rate of return in Excel. But I don't think there's a singular equation for internal rate of return. It's an iterative process. So the next question was, did the number surprise us? So Casey, do you get it? Or have you tried yet?
I tried and it doesn't work.
Oh, thank goodness. I really didn't want to have to buy you dinner in this whole age of Corona everything, right?
Yeah, it's too bad. I would have loved it.
After the baby's born, happy to buy you dinner, okay? So do these two numbers surprise us? And I would say they don't. Do you know why?
Well, it shouldn't surprise because our internal rate of return is positive, which makes sense because our benefits are outweighing our costs.
Right.
So obviously there's a net positive value in doing this. And also like the benefits versus the costs are relatively close together. That's why I'm kind of getting that idea of like, oh, it's like the new minus old over old type of thing.
Yeah, so you're trying to do a percent change.
Yeah, but...
Well, and you're right. Your intuition there is good. When internal rate of return, when net present value is positive, so it's greater than 0, internal rate of return is greater than the discount rate. When net present value is equal to 0, the internal rate of return is the discount rate. And when net present value is less than 0, the internal rate of return is less than the discount rate. So I kind of have a little bit of a litmus test. And we'll do something just super simple here. We'll do like a 2-year net present value calculation, okay? And we'll say that there's an investment that cost us 1,000. So we're going to give it as a negative CFJ. And then in year 1, it's going to give us 1,000. Oh, no, let's say in year 1, it gives us 500 as a positive in cash flow. And in year 2, it gives us 700 as a positive. And let's say that we've got a 5% return. So we're going to look at this and we're going to see the net present value is $111. Given that the net present value is $111, what would we expect to see in terms of the internal rate of return? Do we have any clue at all? When net present value is positive, internal rate of return is greater than the discount rate. So we are expressly positive at 111. So what we know is that it's going to be at least larger than the discount rate we gave it of 5%. Well, let's test that. Red IRR, and in fact, it is greater than 5%. It's quite a bit greater than 5%. That's because 111 is not a trivial percentage of the $1,000 investment. Here's a couple of errors that people make. In addition to the ones that I must have made on some of these earlier rounds, again, I apologize. If there is no cost function, if there's no investment amount, you can't calculate a net present value because there's no investment to net out against the benefit. There's no cost to net against the benefit. So if you put all the numbers in, put them all in as positives, instead of, if you'd forgotten to put the first one in as a negative, it's going to tell you no solution. Or if you don't give it any, cost function, when you click on net present value, what it's actually giving you is present value, not net present value if there's no netting out of a cost function. Or if you actually wanted a present value, but then tried to calculate IRR, the IRR that's going to give you either will be no solution or it will be the discount rate that you used. Okay. Any questions here?
Can I maybe vocalize like the significance of understanding calculating IRR just out loud for a moment?
Yes.
Because what this really is going to do for us is it's going to tell us if we can estimate the cost of a project and also estimate the kind of future cash flows that we'll get by doing this project, then we can determine if that project is going to be worth it based on what the IRR is going to be.
That's exactly right.
Because if it's going to be greater than your discount rate, whatever the discount rate is for your company, then it's worth doing. If it's the same, then it's kind of like it doesn't matter if you do it or not. If it's negative, you should not do that project.
Exactly. So if the net present value is 0, then the discount rate is equal to the internal rate of return. You're getting only what you expected to get. No more, no less. If your net present value is positive, you got more in the way of a return than your discount rate cost you by some little bit. If it's a negative relationship, then your cost of capital was greater than the return you got. Okay.
I have a quick question. So we have some numbers here for our periods and some outlays for those periods. Those are estimations, obviously, like the 90. So obviously we know the first one, 950, we know, okay, that's the upfront, but then 100, 125, 150, and so on. These numbers are, obviously they're informed estimations, but to what extent can they be notional in your experience? Have people used that sort of creativity to justify projects?
All day, every day. Yeah, because you have to recognize, and you're exactly right, we are into guessville here, right? We are supposing, we're forecasting, projecting, we're guessing. We're being scientists, and so we're going to apply the acronym WAG, W-A-G, to our scientific guess. Do you know what that acronym stands for? Wild ass guess. Okay, W-A-G. Because that's all it is. Now, it may be a nicely informed one. I might have lots of good reasons. Maybe there's even some contracts behind this. You're going to go through some problem sets. In fact, not the one for this week, but the one for the next, called Project Investment Selection, and where you'll have 3 different projects looked at 3 different ways with 3 different types of cash flows, and you'll come up with IRR and net present value, and you'll see exactly the virtue of what Casey was trying to tell us about. We use these as decision criteria. In fact, Casey, I'm going to have to renege now on my buying you dinner because you stole my thunder, buddy. These are a set of decision criteria that we can actually break down into some rules, and we'll look at that in a little bit. Okay, Casey's exactly right. I refer to those as the virtue of using NPV and IRR. They help us make decisions. Otherwise, they're just numbers that we can throw up or spit up on a page, right? They help us make decisions. And yeah, they're all guesses. They're all forecasts and projections.
Rick, kind of piggybacking on Emilio's question, I have, and this deals with actually something the capstone I'm working in. So I'm thinking about an established company, and they expand. I don't know. I guess I'm struggling. Where would legitimately I could find a cost? And ends at times 0.
Okay, so let's come back to one of our values, one of our numbers here. I don't want to use that one. I want to use this one. Okay, and we have somehow determined legitimately, and legitimately simply means our best educated guess that makes the most sense to us. That's what legitimately means. Okay. And we believe it's going to spin off 100 and then 125 and 150 and 175 and 200 and have a salvage value of 500. So really for that year, we're calling it 700. And we want to think, what should the cost be? Well, shouldn't the cost, Jason, be equal to the present value?
Yes.
If the discount rate is the reasonably expected return, remember cost and return are 2 sides of the same coin. If the discount rate is the reasonably expected return, then we would think the present value would be the value of the investment in today's dollars, and its cost should be that exact same number. If they are, the net present value is 0, and our internal rate of return and our discount rate were the same number. But I don't know about you, I'm an avowed capitalist. I want to earn more than my discount rate. Maybe my discount rate was 10%, and I would be satisfied with 10. Okay, that's why I set it as my discount rate. Maybe it's my required rate of return as an investor. Or maybe I went out and borrowed money at 10% to put into these investments. So I better earn 10%, otherwise I'm going in the negative. And that's, I don't want that, right? So I'm going to go ahead and say 10% is my discount rate, in which case I want a little bit more. If I borrowed that money in 10%, I don't want to go through all this just to break even and earn nothing. I want to earn more. I want to get maybe 12%. Well, if I end up having an internal rate of return of 12%, I'm a happy guy, because now I know I have a positive net present value, and I got more of a return than my cost of funds were, so I have an economic profit as well. Okay?
Okay.
So let's look at that just a little bit further here, where we had thrown those numbers in. And so here I'm going to say, all right, I know that it should be worth $9.93, but I was able to negotiate a price of $9.50. I'm buying this from my man Nate. He and I have done business together for a lot of years, and I know that I can rely on his projections of cash flows. He's never been off by more than just a tiny amount. But Nate also knows that I want more than a 6% return. Not a lot more. I just want more. So he was willing to sell me this investment at a little bit less than its present value, knowing that that was going to then presumably give me a return slightly greater than the discount rate. Because I get not only the discount rate, but I get this extra $43 of additional value spread out over that time. So it increases my return. Any questions?
So I would need, and I can take this offline because it's not about me, but I would need a cost at some, because I can't figure an internal rate of return based on present values.
You must have a cost.
Must have a cost.
Must have a cost. So let's assume that the project you're thinking about for your capstone is a new production line in a factory of some kind. Well, what's the cost going to be? It's going to be its capital cost. It's going to be the actual cost of the line itself, the cost of the installation of the line. Maybe it's going to be a cost of warehouse expansion. It's going to be what it actually costs you to put it in place.
I can find that now. Thank you.
Don't confuse the cost and expenses as it's going along creating revenue. Those expenses we're going to forecast, and we're going to look at all of this starting next week. We'll start to do some rigorous forecasting next week, and I'll give you some forecast methodologies. So I think over the next couple of weeks, Jason, this is all going to come into very clear focus for you for your capstone.
Perfect. That
helps. I don't think you're the only one in this book. I think there are 2 or 3 in the class that are in that same position with their capstones right now. Okay?